Hey guys, this is Mrs. Herrick trying to set things up in Google Meet and trying to record. So the goal is to start learning about the subatomic particles of atoms. And I'm hoping that you've got some background in protons, neutrons, and electrons, and have heard about these before in your junior high classes. So I'm just trying to get to the right spot here. Here we go. And so just wanted to get to the first first 4 pages of your notes. They should be right at the beginning. It's called Notes 1, Atomic Structure. It's got a bunch of blanks. It has protons, neutrons, electrons in the front. And then you're going to be getting to a table towards like page 3. Anyways, I'm going to get to part of it today, and then I'll explain the last 2 pages of the note packet are actually in a video already posted in Schoology. But I'm hoping to do a visual video with all the handouts too. I just wanted to focus on this one being the notes. The notes that say Notes 1, Atomic Structure. And it says what's inside an atom, okay? We also have a term called an atomic mass unit, and we're going to be talking about what that means too throughout this little lesson. But okay, so what's inside the atom? We've got protons, and they have a positive charge, and it has a mass of 1 AMU. Now what that means is the actual proton is really itsy bitsy. There's a table on the top of your homework pages. I'm going to definitely go through that little top table on the top of your homework pages. I will go through that when we get back together Monday. But the AMU is really tiny. It is absolutely down to the 10 to the minus 24 of a gram. But it's all relative to a certain isotope, a certain atom of carbon. So let's just check it up as whole numbers of mass units for now. And we will try to clear that up when we get together live in the class. Now, protons are found in the nucleus. I'm going to recommend a visual video, really short 10-minute, even 5-minute clip. I'm going to have you watch that first before you get into these notes. But it kind of visualizes everything in case you didn't have a really good background in what's inside the atom. So anyways, the protons are positive. They have an AMU, so they do have a mass unit, and they're found in the nucleus. Okay, then we have neutrons, and they're neutral, and they also have a similar mass to protons. And actually, in reality, neutrons are a little tad bigger than a proton, but overall, in the big size of an atom, which is really tiny in itself, they're pretty much equal, 1 AMU each, okay? And the neutrons have no charge. They are neutral, and they're found in the nucleus as well. Most of the nucleus has the mass, and it has a very nuclear attraction to keep neutrons in the nucleus and protons in the nucleus. This is the essence of all matter, keeping it stable in the nucleus. Now, we also have a lot of radioactive elements out there where the nucleus isn't stable, but we're mostly talking about the stable type atoms out there. And then we have the other part of the atom, and this part is really small, and they're on the outside of the atom. It's called the negative, and they have a negative charge. So protons are in the nucleus with mass, and they're positive. Neutrons are almost like a cousin of protons, but they don't have a charge, but they do have mass. So the mass is in the nucleus, but the negative charged electrons have very little mass. It's almost like 2,000 times smaller. If you would take this little value and flip it over 1 over the number, it'd be almost like saying close to 2,000 times smaller. So because it's so much smaller, we pretty much give it a value of 0. So compared to the proton and neutron, the electrons don't have a mass. Now, technically they do because they're made of matter, but it's so much less that we arbitrarily call it 0 for electrons, okay? And they're found in the electron cloud and it's outside the nucleus. Okay, so we're going to keep going. We have the protons are positive, so just remember P and P, and that we have the neutrons are neutral. Okay, so those two things are key in understanding. So let's actually visualize the atom. So over to your right, it says, how do we draw an atom? So go to that part right to the right of neutrons on your note page, and we're going to be looking at how to draw an atom. We've got these positively charged red round things, and that's the protons. And we've got these white round things, and they have no charge, and they're neutrons. And this is the nucleus. And then we have these green negatively charged things called electrons, and they actually are moving. Now, they show them in these rings and their electron levels. They have different energy amounts, and they're very tiny energy pockets, but the levels are there and they are moving around, but it's more moving around in a three-dimensional kind of thing. And later on, after we do the atom, the main part of the atom, we're going to spend a whole couple, like 4 or 5 days learning how the electrons are arranged. But they are holistically looking like they're in these rings, and that would be very simple to think of. That's fine, but we have 2 of them here. We have 4 of them here. And you'll notice that there are 6 green negatives and there are 6 red positives, and that's what makes the atom neutral. Atoms are neutral. We'll talk about ions that are charged later in our notes, but put this on there, how to draw an atom, draw this out so you know that this part, the red and white, is a nucleus, and the green circles, the circles around it, the purple circles with the green electrons is like the electron cloud. Okay, we'll keep going on. We're going to describe atomic, this is protons and neutrons and electrons, just to kind of label everything. So take a minute to label everything. I forgot that these were in the slides here. So take a minute to get that all drawn, okay, over to the right, and be able to identify these parts. We're going to be having visual atoms, like models of atoms in the room. We're going to be looking at ones, other versions of ones on the computer screen and whatnot. So we're going to have a lot of examples over the next week or so. Okay, so we're going to move on and look at atomic number. It's in the middle of your page 1 here. Atomic number is the number of protons, and every single atom on the chart has a certain number. Every atom has a different number of protons. And if you look on your periodic table, which you should have nearby you right now, you have 118 elements right now. And the last ones from like 93 to 118 have all been man-made in big laboratory equipment. I'll have to show you and talk to you more about that later. But anyways, each element has a certain number of protons, and we call that atomic number. The symbol for atomic number is Z. I'll talk about Z being atomic number. We will refer to that quite often over the next week and through this whole unit through the first week in December. Okay, how's the periodic table arranged? If you look at your table, you'll note that the atomic number, which is the whole number on your periodic table, each element has a whole number on each box on the periodic table, and it's called the number of protons. Okay, it is used to identify the element. Each individual element has a certain number. Different elements don't have the same number. It's always every single one. The first 30, hydrogen, helium, lithium, beryllium, boron, keep going all the way to zinc, number 30. It has 30 protons for the atomic number 30. That's zinc. Or copper has 29, or carbon has 12. Each element has their own atomic number and their whole numbers. They never change in an element. If for whatever reason a proton changes, then the element will change its identity. It's only really used for that. It only really happens with nuclear reactions, and we're not really going to get into that detail here. Okay. For instance, oxygen, if you look on the chart, take a look at O towards the right of the chart, you'll see the number of having, let me put these all out now. Oxygen has 8, If you look at oxygen, if you look at chlorine right to its right, you'll see it has 17 to the right and down, I mean. And then number 3 is lithium. And if you look at atomic number 20, that should be calcium. So take a look at that on your periodic table. You should have your table with you and have it out. Okay, let's keep going. We're going to go on to the next concept. The big concept on this page was atomic number Z. So let's go on to atomic mass. Okay, we're going to do that here in a second. Just wanted to look at your periodic table that the top number of, and it may not be the top, depending on each chart. The atomic number is Z. It's the whole number. On each element's box, you have a symbol, and that represents usually a capital letter and sometimes a second small case letter, depending on the element. We're trying to learn about 50 to 60 elements and being able to know their names. So that's going to be something I would like you to do, to know their names. And we also have the atomic mass. Now on the chart, it's an average. It's an average of the atomic mass. Let me go back here. It's an average. So we might have an isotope. We'll talk about isotopes here in a little bit, but hydrogen has parts of atoms that have only one mass, and some of them have 2, some of them have 3. But the average mass of all those isotopes has this decimal type number. So this is an average mass of all the isotopes of hydrogen. Okay. So just if you want to jot that down, maybe below your atom, just what the box all stands for. I really didn't put a box on your page there. Maybe to the right of the atomic number section, I would label all this. Take a minute here, stop the video and label this so you know what everything means. Remember that the whole number in your each box is the atomic number, the number of protons, and the decimal number is the average mass of all the isotopes. Sometimes we'll use it to get a similar type atomic mass, but this number that's decimaled, it is an average mass. So we'll talk more about how it's not technically an isotope on the chart. It's an average of all the isotopes. And again, I'll explain more what the isotope name means here in a little bit. Okay, so the next big letter, next concept from the periodic table of each element is the atomic mass number. Okay, atomic mass number is the number of protons plus the number of neutrons. You need to add them together, and it will represent the relative mass of an atom, of a single atom. Okay, and it has the symbol A, and remember the atomic number Z. So think about the opposite parts of the alphabet. A is for mass, Z is for protons, okay? And it tells what is in the nucleus. The number of protons and neutrons tell you what's in the nucleus. Remember that the electron has a mass of 0, so all the mass of the atom comes from the nucleus. It's the protons and the neutrons. So we're talking about the atomic number being the protons and the atomic mass being the protons and the neutrons. Okay, so let's move to page 2. Let's look at some examples. We've got some magnesium and some chlorine here. So let's take a look at that. Magnesium has a symbol of Mg. Its Z whole number is 12, okay? But when you look at this isotope over to the right with 26 on top, that's the mass number, and 12 on the bottom, that's the atomic number. Then we're going to be figuring out the number of neutrons. So we're going to say 26 is the mass number in its protons and neutrons, and then the bottom number is Z, is the number of protons. You could even write this down like right there to the right before you get to example 2, just so you know what all the number means. This is called the isotopic way of knowing the mass and atomic number. It's called the isotopic method, okay? But this is a particular type of magnesium. It's called an isotope of magnesium. Okay, so if you look at this, let's go back. This represents how you're going to go ahead and get the neutrons. You're going to take 26 minus 12 to get 14 neutrons. And we're eventually going to figure that out after we go through the next slide looking at chlorine, okay? So chlorine has a symbol of C and L, big C, little l. It's Z, if you look on the chart, over to the far right on the second row is 17. And over here is an isotope of chlorine, a particular isotope with the mass of 35. And so its mass is 35, this particular type of isotope of chlorine, okay? So when we go ahead and figure out the number of neutrons, again, symbols chlorine, zinc is 17, the mass is 35. I wanted to use a new slide and kind of emphasize how we get the neutrons is that we're going to take the proton number and the protons and the neutron numbers, and we're going to be subtracting them. So when you look over to the right, you got 35, the mass number. A is on top of Z. A is the mass. 17 is the atomic number. You just subtract those. And so 35 minus 17 equals 18 neutrons. That's how we're doing that with chlorine, okay? So let's do some more examples. I think you're going to draw in right by the examples. I didn't get a chance to write them in before I printed off the page. So right underneath there, you'll see a P and an N, and a P and an N, and a P and N 3 times. So here, go ahead and write this down. We're writing in the number of neutrons is always going to be the number of protons plus the number of neutrons, and Z equals the number of protons, okay? Then when you get the number of neutrons, you're going to take A minus Z. You're going to take the mass number minus the neutron number, okay? Here's some examples now. So write down H above the first P and N, write down F above the second P and N, and write down N on the third one. And we're going to figure out how many protons and neutrons each one has. So here's H. It has 1 on top and 1 on the bottom. So that means that you're going to have basically protons and neutrons are going to be both be 1. The mass is, this means it has no charge. That's what this top number means. This means the mass. This means the atomic number. And then this means there's no charge. It means you have equal electrons and protons, okay? We go to the next example, put fluorine with 19 on top, and you put 9 on the bottom, and it also has no charge. We're going to put a 0 there for no charge. This means these guys are neutral. The next one is nitrogen being 14 on top, 7 on the bottom, and it also is 0. So what we're doing is filling in what they all mean. Excuse me, I didn't mean to go too fast here. So right here, we're going to take 1 minus 1, and we're going to get 0. Okay, so your first hydrogen is going to be protons. Excuse me, sorry, I didn't mean to move the screen. So here we're going to fill in protons is 1, but because 1 minus 1 makes the neutrons 0. So you're going to put 1 proton and 0 neutrons for hydrogen. The next one here, we have 19 as a mass, 9 as a protons. So you're going to have 9 protons, and you're going to have 19 minus 9, or 10 neutrons. Okay. And then, excuse me, I didn't mean to move the screen here. Sorry. The next one for nitrogen is going to be with 14 as a mass and 7 as protons. You're going to have 7 protons and 7 neutrons. Okay. I'm hoping you got that all filled out. When we get back together, I'll double check that to make sure you figured those out with me not having it in the typed up here. Okay. We're going to go on to isotopes. That's the next slide. Okay. Isotopes are a particular type of atom of an element. Okay. And they're plural because many of the elements have different type of isotopes of the same element. So let's go ahead and write this down. Basically, isotopes are the same elements but have different atomic masses. So they have the same number of neutrons, same number of protons, but different number of neutrons, and that makes their masses different. Okay, and this is due to the number of neutrons. They're the same elements, but they have different masses, and that's due to the number of neutrons. Remember that protons cannot change, so it's the number of neutrons is what makes them different. Every atom is an isotope. Two have to be compared, okay? So the periodic table has the average mass of all the isotopes that element forms, okay? And many isotopes, many of the elements or many of the isotopes have different atomic masses, okay? But what you're seeing on the periodic table is the average mass of all the isotopes. Okay, so here's some examples. Okay, we have N, we have another N, and we have a third N. Let's fill these out and remember that the protons and the electrons are equal because right now we're talking about neutral atoms. Okay, so we have 13 on top, that's the atomic mass, and we have 7 for the protons, and we also have no charge. They're equal. Protons equal electrons. So we're going to make our protons 7 and our electrons 7 just because it's neutral. We're going to do the next one is having a mass of 15. This is a nitrogen that has 15 as a mass as opposed to 13 on the first one. It also has 7 protons because it's nitrogen. They have to have the same number of protons, and it's also neutral. These guys are neutral just because we're focusing only on neutral atoms at the moment. We have a third one, a third type of nitrogen, and this has 14 as a mass. It still has 7 protons, and it's also neutral. So the first one has a mass of 13, the second one has a mass of 15, the third one has a mass of 14, and they all are different atom types of nitrogen. And we call those isotopes of nitrogen. Okay, so when we fill these P's, N's, and E's, actually, it doesn't do that. So let's talk about that here. When you do this here underneath, you're going to have 7 protons and 7 electrons. But the neutrons you're going to subtract 13 minus 7. So you're going to have 6 neutrons for the first one. So you should say 7, 6, and 7 for the first one. The next one's going to be a little different on the number of neutrons, but you still have 7 protons and 7 electrons. It's the neutron number that's going to be different. That's what makes the isotopes different. Still being nitrogen, but having a different mass and different neutrons. But you're going to take 15 minus 7 to get 8. So the first one has 6 neutrons. The second one has 8 neutrons. Now we look at the third one. Again, you have 7 protons, 7 electrons. But when you take 14 minus 7, you're going to get 7 neutrons. Okay, so you're going to have 7 P's and E's for all 3 things. But you're going to have 6 neutrons for the first one, 8 neutrons for the second one, and 7 neutrons for the third one. Again, I will reinforce that when we get together next week, just to visualize that better. Make sure you have those filled in right. Let's move on to this last part of page 2, and this is atoms. Okay, these guys are neutral. I really want to emphasize when we talk about atoms, they have neutral numbers of protons and electrons. Okay, so elements on the periodic table are as atoms because they are neutral and they have a 0 charge. Okay, and you're going to put down, so in an atom, protons are always going to equal the number of electrons. Protons equal electrons. And so the atomic number is the number of protons and the number of electrons. So we have these protons having 6, and when you put them together, that would be like carbon, and so it has 6 electrons to go with it. I didn't quite show that in there. If I was there at the screen, I would probably write those in. But carbon would have 6 electrons with the 6 protons. Okay, let's go on to ions now. We're going to compare ions to atoms. We're now on page 3 of your notes, okay? We're on page 3. So ions are going to be charged atoms, charged particles if he either gained or lost electrons. That's what makes them different. So if you have a negative ion, you always gain an electron because it makes it extra negatives. It has more negatives than positives. Fill in the negative more than the positive. And we call these guys anions and anions, okay? Them positives are atoms that have lost electrons. It has more protons than more protons than electrons. And then the name for this one is going to be a cation. And unfortunately, my thing is not showing that, but the word cations literally like cat and ion. So I wish this would go away so you guys can see the spelling. It's literally cat and ion. Okay, cation. Okay, just like a 6-letter word, cat, and then put ion beside it. And that's what we call it. Let's do these examples here. We have lithium, number of protons. Looking at the periodic table, you should see that it has a big number 3 by lithium. That makes the number of protons 3. But since it's 0, then it has the same number of electrons. 0 means you have protons, electrons the same. But when you have a +1 lithium, which is very common for lithium being in the first column, then it means that you've lost an electron and you're more positives than electrons. That means your number of electrons is going to be 2. Okay? So right now we're going to stop here. I do have a simulation, but I'd rather show you a little bit more. I think the video went too long, but I will definitely show you this simulation later. But we're going to help you fill out the bottom table on page 3 in the next video, just because I want to end it right now. I think it's a little too much. It's been a little bit of a long video. So take a break and we'll come back into filling in the table on the bottom of page 3.